Most essential learning competencies. Explain the properties of solids, liquids, and gases based on the particle nature of matter. The Earth's atmosphere is made up of gases like oxygen, nitrogen, carbon dioxide, and other gases. The behavior of solids and liquids can easily be described because they are more visible than gas. We use water in cleaning, taking a bath, cooking, and other activities. We drink also water and other liquids. Solids are also tangible. We handle them, we wear them, and we use them daily. In this video, we will explain the physical properties of solids, liquids, and gases based on the particle nature of matter. We survive because of oxygen gas, and somehow we are not yet familiar in their properties, unlike solids and gases that we can predict and describe their behavior because they are more visible. Physical properties can be measured and observed without changing the composition or identity of the substance. The different physical properties of matter in this video are boiling point, melting point, density, and specific gravity. Okay, so let's start. Boiling point. Boiling point refers to the temperature at which the pressure of the vapor escaping from the liquids equals the pressure of gas above it. The boiling point of a liquid may vary with atmospheric pressure which changes altitude. At sea level, the water boils at 100 degrees Celsius, where the atmospheric pressure is 1 atmosphere. When a liquid is heated to its boiling point, many of its particles have enough kinetic energy to vaporize. At higher atmospheric pressure, the boiling point of liquid increases because the particles in the liquid need more kinetic energy to escape. At high pressure, in the pressure cooker, water boils at 100 degrees Celsius. At higher altitude, atmospheric pressure is lower than the sea level. Thus, the liquid boils at lower temperature. The boiling point is lower at mountainous areas where altitude is high. Water, which usually boils at 100 degrees Celsius, will boil at slightly lower than 100 degrees Celsius at higher places. Bubbles of gas form throughout the liquid and move to the surface, leaving the liquid phase. The gaseous water molecules that form above the boiling water is called steam. The particles with the highest kinetic energy escape first when a liquid is at its boiling point. If no more heat is applied, the temperature of the liquid drops below its boiling point. If more heat is applied, more particles acquired more kinetic energy to escape. The results are continual cooling effect on the liquid. Therefore, the temperature of a boiling liquid never rises above its boiling point. When heat is applied, the liquid only boils faster. Eventually, all the liquid boils away. Take note that the boiling point of liquid substances is different from one another because of its reaction to heat and arrangement of their molecules. Since the kinetic energy of the molecules is proportional to its temperature, evaporation of some liquids happen at higher temperature. Melting point. Solid particles are packed against one another in a highly organized pattern. Solids are dense and incompressible. Solids do not flow because of the fixed position of most of their particles. When you heat a solid, its particles vibrate more rapidly and begin to spin as their kinetic energy increases. The particles within the solid crumbles and eventually the solid melts. When heat is applied to a solid, its temperature rises, causing the particles to vibrate rapidly and move farther apart. The vibrating particles will reach a point where they can no longer retain their orderly arrangement. When this happens, the temperature has reached the melting point of the solid and the solid melts. Melting point is the temperature at which solid turns into liquid. If more heat is added, the liquid particles move even faster and farther apart, such that they become independent on one another. Ionic solids have high melting point than molecular solids. Not all solid melts. Wood, for example, decomposes when heated. Density. Density is an intensive property that does not depend on quantity of mass present. Density is a measure of how much matter is in a given amount of matter. The amount of matter in a body is called space, while the space occupied by matter is called volume. This table shows you the states of matter, distance between particle, and its density. The particles of solid are very close together. Its density is high or very high. In liquid, its distance between particles is slightly further apart than solid, and its density is slightly less than solid. While in gas, the distance between particles is very farther apart than a solid or liquid, and its density is very much less than solid or liquids. The difference between the densities of solids, liquids, and gases is due to the distance between the particles in each states of matter. Solids have the highest density because of the close packing of molecules. Water is unusual because it expands slightly when it freezes, making it less dense. Thus, ice floats in water. Pure water has a density of 1 gram per cubic centimeter. Therefore, any substance with a density less than 1 gram per cubic centimeter will float, and any substance greater than 1 gram per cubic centimeter will sink in water. Thus, it is sometimes easier to swim in a seawater than in a river or a pool because seawater contains salt. The salt increases the density of water so the body sinks less in it and it is easy to swim. Density of a solid is slightly greater than that of a liquid, and the density of liquid in turn is much greater than that of a gas. The density of water in its liquid state is greater than that of its solid states. This table shows the densities of some common materials. Specific gravity. Specific gravity is the ratio between the density of a solid or liquid to the density of water at 4 degrees Celsius or 1 gram per cubic centimeter, or the ratio of the density of gas to the density of dry air at standard temperature and pressure. Specific gravity is equal to the density of the object over the density of the water. The specific gravity can tell us if the object will sink or float in our reference substance, usually water, at density of 1 gram per cubic centimeter. If the specific gravity is greater than 1, it means that the material is denser than pure water. Thus, it will sink. A material with a specific gravity less than 1 or less dense than water and will float on the pure liquid. If the specific gravity is equal to 1, the object will neither sink nor float. This is important in jewelry business. If a gold is genuine, then it should be denser than water. The density of gold is 19 gram per cubic centimeter. All matter consists of pure substances or mixtures. A pure substance is a kind of matter that cannot be separated into other kinds of matter by any physical process. Pure substances are of two types. We have elements and compounds. An element is a substance that made with one kind of atom and it cannot be decomposed by any chemical reaction into simpler substances. A compound, sometimes called a chemical compound, is a substance composed of two or more elements combined in definite proportions. A compound has properties different from those of its component elements. Most of the materials around us are mixtures. A mixture can be separated by physical means into two or more substances. Unlike compound, a mixture has a variable composition. There are two types of mixture: homogeneous mixture and heterogeneous mixture. A homogeneous mixture, or also known as a solution, consists of two or more kinds of elements or compounds physically combined and exist in one phase. Each component can be separated by physical means. A heterogeneous mixture, or colloid and suspension, consists of two or more phases which can be separated by physical means such as hand sorting or picking, sieving, filtration, and others.